Okay, good afternoon. So I will continue the lesson by more differentiation rules. Uh, I told you to go through the video that I uploaded before, but let me just review it very fast. So we learned about the derivative of a function f, which is the limit of f of x plus h minus f of x over h, then h goes to 0, okay? And then we had some table to have some particular functions and derivatives tabulated there. For example, if you have f of x, f prime of x, for example, we saw that if I have a constant function, its derivative is 0. If we have x to power, say, a constant, the derivative is this one. And then we want to add more functions to this table. And then we also had some rules. For example, if I have a constant function, constant number multiplied by a function, if I want to take the derivative, it becomes cf prime. If I have the sum of two functions, I want to take the derivative, it becomes f prime plus g prime. And if I have the difference, it becomes that. And then I had also the chain rule, yes, which was probably the pinnacle of these rules. Yes, this becomes f prime of g of x multiplied by g prime of x. So my goal is today is to add more functions to the table, as well as two more rules here. Okay? Okay, so the first thing is that we want to talk about trigonometric functions. Okay, the first thing that we want to discuss about is what happens if I have sine x here. And we want to answer the question, what is the derivative of sine function? Okay, so here I would say that f of x is sine x. Let me emphasize, this is extremely important. X is expressed in radians. And then we want to answer the question, what is the derivative? Okay, so I will use the formula. Whenever I want to discover the formula for a new function, there's only one way for me to do it, and that is going to use the derivative formula. So what we write f prime of x is equal to the limit f of x plus h, means replace the input of my function with x plus h. So this becomes sine of x plus h minus f of x, which is sine x, divided by h. H goes to 0. Of course, calculating this limit is beyond the level of your lesson. I will follow exactly what is written in the book, okay? The first part, of course, is easy. I use the addition formula here. I have it in my memory, so I use it. Sine of the sum of two angles is the sine of the first one multiplied by the cosine of the second one plus the other way around, yes? Sine of the second one multiplied by the cosine of the first one. So what you see here that I have written is just the expansion of that using the addition formula for sine. And then I have minus sine x coming after that, and then divided by h goes to 0. So what happens now, I have to calculate this limit. So to calculate this limit, I reorganize it a little bit. For example, between these two, I can factor a sine x out. And here, this becomes cosine of h minus 1. And then I copy and paste this part as it is here. And then divide it by h goes to 0. Yes? But I can separately divide them. So I have the sum of two numbers divided by h. I can divide the first number by h plus the second number by h. And when I divide this by h, I write it slightly different. I would write it like this. And then here, I would write it like this. H goes to 0. Okay, so let me know if you don't understand something. Is it clear? Okay. Now h goes to 0, it means that x is considered to be fixed as far as this limit is concerned, yes? Because I am making h smaller and smaller. I have nothing to do with sine x and cosine x. So this part will be affected because I am changing the value of h and making it smaller and smaller. This part will also be affected because they depend on h, but not these two parts. So if I want to do these two rigorously, that is what I said. It is a little bit beyond your lesson. So I will follow what is written on the book. So, but of course you have intuition what to do. Yes, if I give you a calculator and I ask you to guess what will be this limit, what you do, you start calculating this for a smaller and a smaller values for h to see what is happening to the value. And the same thing here. I just want you to show, for saving time, I just want you to show what is here. So you see, this is the table that I want to discuss about. So this also mentioned, it is extremely important, h is in radians. Otherwise, these numbers will be quite different. So if you want to do the same thing in degrees, the numbers that you get by your calculator will be different if you switch your calculator in the degree mode. So what matters here is that you have to switch to radian mode and then start making h smaller and smaller so that it becomes closer and closer to 0. For example, if you choose 0.1 and calculate this using your calculator, according to the book, you will get this number. And if you calculate this according to the book, you will get this number. And now let us make this h even smaller. I want to get closer to 0. When I choose this, you will get these numbers. I don't know, when you choose this, you will get these numbers. And when you choose even a smaller number, you will get these numbers. I think it is very clear what is happening to this fraction. This fraction has this number, then this, and this. So it is clear it is getting closer and closer to which value? 1. Yes? And what about the other one? What do you think? It becomes 0, yes? So it is getting closer, closer, and 0. It's becoming very small and small. Okay, so the only non-rigorous part of my argument is this part, because if I want to calculate these limits rigorously, it would need some theorems that you haven't studied yet. Okay, so hope you agree with me. According, at least intuitively, it should be correct for you. It should seem plausible that this goes to 0 and this goes to 1. Okay, then it becomes very clear. If this limit is 0, 0 multiplied by sine x is 0. If this limit is 1, 1 times cosine x is cosine x. So the answer that you will get is cosine x. So that is interesting, you see. The derivative of sine x is cosine x. So this is something that you just learned. But hopefully, now that you know the chain rule, you can answer a lot of questions, not just sine x. The chain rule version of that will be like this. I told you that this is the only thing that you get in the formula sheet, but what is the chain rule version of that? What do I mean? Instead of having sine x, let us have sine of u, where u is a function of x, and you're interested in calculating its derivative. It follows the same rule, but do you remember what is the difference? The difference is that you have to multiply by an extra u prime factor. So that's the only difference if you have exactly as before. So whenever you learn a new rule, you can also translate it in the chain rule language, which is the important part. So let me give you some example. So I would say differentiate. So number 1, f of x is equal to, for example, sine of 5x squared plus 2x minus 1. Everything is in radians. Yes? So if I want to take the derivative of this function, if I want to differentiate this function, this rule is not enough because this only gives you what is the derivative of sine x. This is not sine x, this is sine of 5x squared plus 2x minus 1. So you need to combine this with the chain rule. So this is the chain rule version, which you will not get in the formulation. Okay, so you need to give the role of this to you, give the role of u to this one in your head, then you will have sine u. So if I ask you what is the derivative becomes cosine of u. Be careful, if you stop here, it's not complete. But multiplied by u prime. Yes? And then you have to continue until there is no prime left. So you copy and paste the first part, and then you multiply it by this, the derivative of that, which is 10x plus 2. And that's it. So that is the answer that I expect you to write down. Yes? Is that clear? But let me write an example. This is my experience. Some students make mistake here. I don't know why. I usually always teach it in my teaching, but it doesn't matter. You will do mistakes probably. So I would say sine to the power of 3. Now let me write square root of, let me make it a little bit, let me give a harder one later, but let me just write 2x squared plus 2. We want to differentiate this function. So you immediately realize that you cannot use the formulas because this formula tells you the derivative of sine x only. Even this formula is not enough because here you do not have any powers for sine. So it is a chain rule, but not just simple version of that. So how should you interpret this? You need to have this trick to take something to be u first. But you need to be a little bit skillful in taking u. For example, what do you think I will take u first in my head? Yeah?
The entire sine.
Yeah, that's good. So you just give the correct answer. Because usually people say this. And that is not good here, yes? Do you understand why? Because if I take this one to be u, then I will have sine u to power 3. Sine u to power 3 is useless now. Because it is neither this formula or it is no formula that I have it here. So taking this u right now is not useful. Okay, so this is not going to work for you. But as you mentioned, taking the whole expression here, u, is a good idea. Because if I take the whole expression to be u, then the function that I am dealing with is u to power 3. Do I know how to do this? Yes. What's the answer? 3 goes down, then u to power 2, but you have to multiply by u prime. So this is a good idea. So we take this one u in our head and start differentiation. So what happens if prime of x becomes 3 u squared? This is my u. So u squared means sine to the power of 2 of 2x squared plus 2. But the important thing is that it is not finished yet. So you have to multiply it by u prime. This was your u. So multiplied by u prime means multiplication by this. Yes? But now I have to calculate this part because there is a prime left there. Now this is good to take this u in your head. Because now this becomes sine u prime and sine u prime is already on the board, yes? So then it means that you have to copy and paste the first part. which is 3 sine squared 2x squared plus 2, and then you multiply it by sine u prime. Sine u prime is cosine u, but multiplied by u prime. But the last part is extremely simple, yes? So the answer to this is how much? Is 4x. I prefer to multiply 4x here. It doesn't matter, of course, but let us be organized. So 4x multiplied by 3, it becomes 12x. Then I have sine to the power of 2, 2x squared plus 2, multiplied by cosine 2x squared plus 2. This is the answer that you're supposed to give for this derivative. Yes? Okay, so that is easy. Okay, now we want to answer another question. What happens, of course, the natural question is that, what happens if I start with cosine? What do I get for the derivative of cosine? Now, I think it is also good if I write these formulas here for you as well, okay? So the limit of cosine h minus 1 over h was 0 when h goes to 0, but the limit of sine h over h when h goes to 0 is 1. It doesn't hurt if you have it somewhere that you can see. Of course, if I ask you what do you think I will do, you might say that, okay, you will start with the same formula, but instead of having sine, this time you have cosine, and then you will have cosine of x plus h, but don't worry because we have also the addition formula for cosine. This definitely will work, but I want to change my strategy, not because this is wrong, it is correct, but let us change it and make it a little bit simpler. Okay, so can you tell me what I'm going to do now? So one way of calculating the derivative of cosine, as I mentioned, is following the same path. But another way is also to do it a little bit differently. Can you say how? So my question is this. F of x is cosine x this time. Again, x is in radians. The question is, what is f prime of x? Okay, so let me tell you something, might be then you will understand. Do you agree with me that I can write cosine x as sine of pi over 2 minus x? Do you agree with this one? So first of all, tell me, do you agree that this function and this function are the same? Why is that? Because pi over 2 minus x is the complement to x. Because x plus that is pi over 2. So this means that these two angles are complementary. So cosine of one of them is equal to the sine of the other one. Okay, first of all, this is true. Now, of course, this is true, but why this is useful in this context? How can I use the information on the board to find the derivative of this function? How can I do that? Yes?
You can use it first with sine x and use that
As u.
Yeah.
Exactly. Thank you. So this I will take u here in my head. So then it becomes sine u. And if I ask you, do you know the derivative of sine u? You answer yes, it is cosine u, which is cosine of pi over 2 minus x, but multiplied by u prime. Okay, first of all, I want to make sure that you understand what is going on. So this function was my original function. I want to find its derivative. I can use the formula for the derivative, but I want to find a different way. I want to solve it in a different way. It is easier. What I did, I rewrote this in terms of sine, and I gave the role of u to this expression, then I will have sine u, so I can use the result that I just got. So it becomes the cosine of u, but multiplied by u. Okay, but can I write something simpler for this part? It is sine x, because that's the same story. Pi over 2 minus x is the complement to x. So cosine of that is equal to sine of x. So instead of this, I would write sine of x multiplied. What is the derivative here? What? Yes? Minus 1, yes. And then this becomes minus sine x. So what I have to add there is that the derivative of cosine is not exactly sine, it is negative sine. You see, the derivative of sine is exactly cosine, but the derivative of cosine is not exactly sine, it is negative of sine. So let me go and complete this. So this is negative cosine. Oh, sorry, negative sine, sorry. Negative sine. Okay, as I told you, whenever you discover a new formula, you can immediately write the chain rule version of that formula. So what we learned is that f of x is equal to cosine x. We learned that the derivative of this function is negative sine x. Now my question is that if I give you cosine of not just x, but of u, and then I ask you to differentiate that, what's the answer? It follows the same rule, which becomes minus sine u, but the only thing that you have to remember is not to stop here, and you have to multiply by an extra u prime, and I always tell you that this is not in the formula sheet. So is that clear? So of course you can write different examples. For example, I give you a function f of x to be sine 2x plus cosine to the power of 3x. You want to differentiate this function. If you understand what is going on here, it means that you really understood everything. So if I want to differentiate this function, first what I have to do, there is one of these rules. Which rule I have to use first? Yes, let me put this a little bit over. So which of these rules is important right now? The table or these formulas here? Which one I use first? This is what? This is the sum of two functions. Yes? So if I ask you to find the derivative of this function, you don't need to write all these details, but you need to think in this way. So what I do, I will think in this way that, okay, I want to take the derivative of this function. And then I see that this is the sum of two functions. So first I apply the plus version of this formula to write it as what? Sine of 2x prime. I don't insist you to write these all details in the exam, but you need to think in that way. If you want, you can just skip one part, but you shouldn't skip thinking about it in this way. Okay? So can you tell me what is the derivative of sine 2x? The formula is on the board. You can give the rule of u, the rule of u to 2x. So what's the answer?
Cosine 2x times 2.
Times 2. Do you agree? Because cosine 2x, but you should be you should multiply it by the derivative of u, which is 2x. Its derivative is 2, but instead of writing 2 here, it's more common to write 2 here. Yes? So it becomes 2 cosine 2x. Okay, but the next one is something related to our new lesson, and of course some old lessons. So how can I solve this one now? Cosine x to power 3. What should I do? Yes?
Take cosine x
As u. In your head, you can take this as u. Then what do you have? You will have u to the third. And then you want to take the derivative of that. This is something simple. It is 3u to the power of 2, but multiplied by u prime. Yeah, so I will do the same thing here. So 3 goes down, and then u to power 2, which is cosine to the power of 2x. But it is not finished, but I have to multiply it by cosine of x prime. It is not finished because there is 1 prime left, but this is exactly what we just learned. The derivative of cosine x is negative sine x. And I just write it here. So this becomes 2 cosine 2x, and then it becomes negative 3 cosine to the power of 2x times sine x. So that is the derivative of that function. Yeah, is that clear? Okay, but I forgot to write this you had from Math 3C. I have already talked about that. So there is also another formula in this table. Do you remember what is that? So if you have e to power x, what is its derivative? It is e to power x itself. This we had before. I forgot to write it there. But today we want to talk about the derivative of another function which is related to e to power x. What that function is, do you think? You usually learn them together. Yes?
I don't know if it's the function ln.
ln, yes, ln of x, yes. So the question is that if I have a logarithmic function ln of x, we want to answer what is its derivative. Yes? Again, this is one of those problems that if you want to use this, the limit involved becomes above your lesson, beyond the scope of this lesson. So we found another way, okay? So the question is that I want to calculate the derivative of ln of x. But of course, there is something that you have respect for, is ln of x is not defined if x is negative. So whenever I say the derivative of ln x, I always mean x is positive. Okay, so what can I do? Yeah, it might be a little bit confusing. So my question is this: why is ln of x? X is positive, of course. And the question is that what is y prime? I want to answer this question. So what can I do? I would say that, okay, either, of course, I can use this trick, which is not possible at this level. So we change our strategy by saying that if y is ln of x, okay, can you fill this gap for me? I would say that x is equal to what? This is the definition of the logarithm, yes? Yes? E to the power of y. Yes? But now what we do, we differentiate both sides. We say that x is this guy, okay? So this means that the derivative of the left-hand side is equal to the derivative of the right-hand side. This is sometimes confusing for students. I want to make sure that you understand that. What is the answer to the left side? X prime. Yeah, that's the standard. What's wrong? But the point is that, can you answer what is the right side? Of course, it should be somehow related to this line, but there is one difference here. Here it is x, here it is y. You might say, okay, there is no difference between x and y, but is there any difference between x and y? Yes?
Is it 0? I don't know.
No, it's not 0. Because it is not constant. Because you see, y is not constant. I understand what is your concern. You see that y is something that depends on x. When I start changing x, I cannot keep y fixed. It's a consequence of changing x, yes? It automatically changes. Even though x does not appear exactly here, it's not it's different. I understand what you're saying, but I want you to feel it is different from saying that e to power pi. Yes? Because pi is a fixed number, so this is really fixed. Even if I say e to power a, and a is a constant, if I ask you what is this one, then you say 0 again. But I want you to understand, that's why I'm saying it's a little bit confusing. Why you see that appears here is not something new. It's the same y that was here. And this y is really not constant. Because when I change x, automatically y also changes. So this means y is not a constant. Okay, this is something, first of all. Okay, this is not 0. Okay, the next guess. What it should be? If I ask you what is y, do you buy this sentence from me that y is a function of x? Do you understand that? If I tell you that y is a function of x, do you agree with me? Because that y that appears here is the same y that appears here, and y is a function of x. So this y is also a function of x. Now, can you tell me what will be the derivative at the end? The derivative of e to power x is e to power x. So what should I write? It's a little bit confusing. So I would write e to power y. But is it finished? No, because y is a function of x. So according to the chain rule, I have to multiply by extra y prime. Yes? So if I tell you, so let me just tell you something. Ex, the derivative of ex is e to the x. If I ask you what is the derivative of e to the power of x squared, by the way, how do you answer that question? How do you answer this question? So it shouldn't be hard, because I told you that whenever I write a formula here, which you will get in the formula sheet, you yourself should be able to generate a chain rule version of that formula. Yes? So let me just repeat, this is important. If you haven't understood this, might be problematic. So you see, assume that you know it from Math 3C that the derivative of this is this. Okay? Now my question is that whenever you have a formula in that table, there is a chain rule version counterpart for that formula. So now can you help me to write that counterpart here? The chain rule version means e to power u prime. So how should I write the chain rule? This is something that you need to know, because I told you these formulas are not in the formula sheet. This is given to you in that formula sheet. Using that, you should be able to generate this yourself. So what's the answer to this?
You do that times another, like u prime, or like...
Just read it for me. What should I write in front?
Is it e to power u, and then another e to power u prime, isn't it?
No.
U prime.
And just u prime.
Okay, yeah.
Just u prime. Yes? Whenever you have a formula there, change x to u and multiply it by an extra u prime. This will give you the chain rule version of the exact same formula. So might be, let us practice here. If I ask you what is the derivative of e to power x squared, what do? You cannot use this formula because this formula only works for x. This is not x, this is x squared. So what I do, in my head, I will take this one to be u, and then it becomes eu prime. The chain rule version of that is here, so this becomes e to the power of u, which is x squared, but it is not finished. I have to multiply it by x squared prime, which then becomes 2x e to power x squared. Yes? Is that clear? So if you don't know this, write this. I mean, I told you that these formulas are not in the formula sheet. So from here, you should learn to write the chain rule version yourself. And the recipe is this. Replace x with u and just multiply by u prime. That's it. Yes? Okay, now this is exactly the same idea. But the only problem is that y is playing the role of u. Yes, so this becomes e to power y multiplied by y prime. I want you to understand it is not a circular argument. It seems that I am playing around with letters. Okay, it's not like that. Because y is my dependent variable, x is my independent variable. Y is a function of x. So even though you do not see inside y, but y is a function of x. Which function? ln of x. Yes? So hopefully you now understand what is going on. Yes? But what was my question? My question was to find y prime. So I can find y prime here. So I divide everything by e to power y. So this becomes 1 over e to power y is equal to y prime. Yes? So this is the derivative of the ln of x. But this is a little bit strange, yes? Because when you have a function which is expressed in terms of x, you expect the derivative also be expressed in terms of x. But here, the derivative is expressed in terms of y. But this is a minor problem, yes? Because e to power y is nothing except x. So then you take this away and put x. So then it means that finally y prime is 1 over x. So that's also a strange answer you might not be able to guess. So the derivative has nothing to do with logarithm at all. Yes? So if you start with an exponential function, its derivative is more or less the same thing. Yes, in this case, exactly the same thing. But if you start with ln of x, the derivative of ln of x is not logarithmic at all. It's 1 over x. Okay, let us practice this idea once more. This is the only one given to you in the formula sheet. So you need to be able to generate the chain rule version of that. Okay, so what was the recipe? I want to generate the chain rule version for that. So ln of u prime. So what should I write? What should I write? Come on, the recipe is so simple. Change x to u and multiply by u prime. Yes? Change x to u, it's 1 over u, and then multiply by u. Yes? For this special case, I myself prefer to write it in that way, u prime over u. Because 1 over u times u prime is exactly the same as u prime over u. Yes? So the reason that I write it in this way, because some hard problems in integration is related to this. But for the time being, it doesn't. So if you want to take the derivative of ln of something, you'd write the derivative of that something in the numerator and the something itself in the denominator, yes?
So if you want to write it in terms of x, you do x prime divided by x.
Yes, but x prime is 1. This is why you always get 1 over x. Yes? I mean, always, You can go the other way around, but the other way around is useless, yes? Because x prime is always 1. Okay, so for example, if I give you this function, ln of 2x squared plus 1, and I ask you what is the derivative of this function. So how should I do that? This is very simple again, yes? So this is u in your head, and then you use this rule. So the derivative f prime of x is what? 1 divided by 2x squared plus 1, but you need to remember to multiply by this one as well. And of course, you continue to simplify that. So the 2x squared plus 1, the answer to this is 4x. Of course, it doesn't hurt if you put 4x here, but I prefer to write 4x here. One more example. So let me write g of x, ln of square root of x to the power of 2. Okay, let me make it a little bit harder. So x squared plus 2x. And let me make it 4. Okay, it doesn't matter. By the way, ln is like sine and cosine. When I put 4 here, I mean the whole expression to power 4. So if you want, you can write it. So ln to the power of cx means ln of x totally to power c. Okay, can you tell me how should I start? This is, if you really can solve this problem, it means that you really understand everything about differentiation and chain rule and everything. Okay, so if you want to do this, you know that this is a combination of a polynomial, a squaring function, logarithmic ln function. So you have a lot of information there, but you need to find the best one to start with. So how do you start? Yes?
The ln function is u.
The ln of the whole expression to be u. Okay, so you have to take this in your head to be u. This is the only choice for you at this stage. Why is this good? Because if I take the whole thing u, then there is a power of 4 here, so I will face with the function u to the power of 4, which I know how to deal with, yes? So the derivative becomes this function, its derivative is 4 goes down, but u to power 3, this is my u to power 3 becomes this, but multiplied by u prime. This is my u, so multiplied by that prime. Okay, then what? I have to copy and paste this part. There is a prime here. So again, I have to take something to be u. What is good to take to u here?
The square root.
The square root, yes? So I will take this to be u in my head. So what I do, I have 4. This is the copy-paste part. This is ln of u prime, but it is still on the board. Ln of u prime is 1 over u multiplied by u prime. So this becomes 1 over u multiplied by u prime. Yes? But now I give the role of u again to this. Now you understand why this is called the chain rule. It's coming one after the other. But then this is a famous formula. Hopefully you remember that. What was that? You remember square root of u prime is what? It's 1 over 2 square root of u, but multiplied by u prime. So I will continue. So I have to copy and paste. So if you don't mind, let me write them compactly, one below the other. So this becomes 4 ln of 3 ln to the power of 3x squared plus 2x divided by this multiplied by 1 over 2 square root of x squared plus 2x. But it is not finished, multiplied by u prime. But let us do the u prime in our head. It becomes 2x plus 2. Okay. 2x plus 2. Yes? So that's the end of the problem. But of course, if you want, you can factor the 2 out. This will cancel this 2. Square root of they multiply together. You can get rid of the square root sign. But that is minor things. My main concern here is to differentiate properly. Yes, is that clear? Okay, so this is also something we put here. Now I want to add 2 more rules here and then we are done. No, there's also one function. You see, we talked about sine, we talked about cosine, but for some reason I didn't talk about tangent. The reason is that we couldn't calculate the derivative of tangent at this point, but later I will also add tangent and that will finalize. So we will add 2 more rules here and 1 function here. That would be the whole functions that you will study. But in the university, these rules are the only ones, but you will start adding rules here. Okay, so these are the 2 rules that I want to talk about today, are the product and quotient rules. Okay, so let us just start with the product rule. Okay, to motivate you about that, this rule is really needed. For example, if I give you this function, f of x equals to x multiplied by e to power x. So if I ask you, do you know the derivative of x? The answer is yes, the derivative is 1. Do you know the derivative of e to power x? The answer is yes, it is the function itself. But there is no guarantee that the derivative of the product is somehow related to the derivatives of each one of these functions individually. And this is the idea of the product rule. The product rule tells you that yes, there is a connection between the derivative of the product of 2 functions. But the rule is not as simple as before, that you can take the derivative of this and the derivative of that. So let me write the wrong version and cross it over. This is not the correct version. The correct version is more complicated than that, okay? This becomes the derivative of the first one multiplied by the second one itself plus the first one itself multiplied by the derivative of the second. So that is called the product rule. We can talk about why this formula is correct, but for the time being, let us use it. For example, can I use it to take the derivative of this function? The answer is yes. So how do you do that? So the derivative of this function is equal to x times e to power x totally prime. According to this rule, it becomes the derivative of the first one multiplied by the second function itself, but plus the first one multiplied by the derivative of the second one itself, but the derivative of the second one. But then it becomes very simple. Everyone knows that the derivative of x is 1 multiplied by e to power x plus x multiplied by the derivative of e to power x, which is one of those exceptions that its derivative becomes itself. So it is interesting. You see the derivative of this function is this function. And then of course you can combine all these rules in one problem. I mean, so you have to be able to, for example, let me give you an example. What do you think will happen? Let me start with another simple one. X to power 2 multiplied by ln of x. So you want to take the derivative of this function. First of all, do you feel that this is the new lesson? Why? Because this is a product of two functions. So this means that I have to use the product. So the derivative becomes the derivative of the first one multiplied by the second one itself, but plus the first one multiplied by the derivative of the second one. Okay, so what happens now? So f prime of x is equal, the derivative of x squared is simply 2x. I multiply it by ln of x. But we just learned about the derivative of ln of x. I erased that, yes. Oh, it's 1 over x, yes. So this becomes x squared, which is this one, but multiplied by 1 over x. But this is so simple, let me simplify this. One of this x squared and this x are simplified. So f prime of x is 2x times ln of x plus 1 extra x. Okay, I usually should ask what is the answer, but now I ask you what's the question. You should have a question here. What the question is? Not for this, in general. Yes? What is the question now? Yes? No, forget about this. Talk about the product rule. There should be a question in the product rule. Yes, what that question is. What happens if you can come? No.
You divide.
No. No, divide is the topic of the next. Now, even for the product, what happens if, for example, what happens if I have this? So this is a product, but this is more than two functions. So what happens if I have a function like this? What do you think I will do? So this is the question. What happens for the product rule? Still, I need to address this question to make sure that we know everything about that. The question is, if I give you three functions multiplied, and then I ask you to differentiate that. But you have to be able to defend it, okay? Yes.
I'm thinking like, don't you do for the first two ones, and when you're done with that, you add the second, like.
The idea might be correct, but can you foresee what will happen for the final result?
No, not really. Well,
Okay, but can you tell me what to do? What did you say to do?
so I'm thinking like if you do f prime times g and then times g prime times f, and then when you have the answer to that, you add on like.
No, but you cannot momentarily put h away.
You cannot.
No.
Okay.
Because you need to think about this. This is always a product of three functions. You can view it as two functions, not the way that you mentioned, by looking at it in this way. This I agree. So this means that I have the product of three functions. I can multiply two of them and give it a name, for example, in my head to be capital G. So if I call this product capital G, then I am facing with the product of two functions again. Yes? So what happens? According to the product rule for two functions, this becomes the derivative of the first one multiplied by the second one itself, plus the first one multiplied by the derivative of the second. So you are right in this way. If you mean this, I don't know. So then what happens? I have to get rid of capital G because capital G was something I brought in. So, but it is easy to get rid here because capital G is nothing except GH. So I would write F prime GH. But here I have G prime. So, but what is G prime? Capital G prime means GH prime. Yes? But GH prime is G prime H plus GH prime, according to the product rule for two functions, yes? And then I put this back here, and then multiply this in. So then it becomes F prime GH plus FG prime H plus FGH prime. This is the final. So this means that if you have the product of two functions, the rule is this. But using this idea, using this formula and this idea of combining two of them into one function and do some calculations, I end up with this formula. But now hopefully the pattern reveals itself to you, yes? So can you tell me, for example, what happens if I have four functions? F, G, H, S, and then I want to take prime. Hopefully the pattern is now clear, yes? What I'm supposed to do? So here what happened? F prime but GH. F G prime H, F G H prime, yes?
You put like FG together and HS together?
No, I want to find out the result. Of course, you are right. If I want to calculate, I can take these two together, and do the process. But I just want you to see what will happen at the end. Yes?
So the prime becomes on the F first, and then lastly it becomes on the S.
Yeah, it goes for it. Yes?
Okay.
So exactly. So it becomes F prime, but GHS themselves. And then it becomes F G prime HS. Then it becomes F G H prime S. And then finally it becomes F G H S prime. Of course, I'm counting on your intuition about that. But if you really want to prove it, there is one way to prove it, and that's mathematical induction. Because then I will have n functions, and then I want to prove this. But it is not hard to see what is going on. So if I have more than two functions, the rule is also clear, yes? For example, let me solve this problem for you. Okay, so I would say f of x is equal to x ln of x times sine of x. So how should I do that? So f prime, let us just do as much as possible in our head, yes? I want you to see that this is the product of three functions. So if I want to take the derivative, I take the derivative of the first one, but I will not touch the second one and the third. The derivative of the first one is just 1. This is the first term. And then plus, I will not touch the first one. I will not touch the last one. But I will take the derivative of the middle one, which is on the board. Yes, it's 1 over x. And then finally plus, I will not touch the first and the second one, but I take the derivative of the last one, which is on the board. The derivative of sine is cosine. And this is the answer to the problem. If you want here, this is so simple. Let us simplify that. So the derivative becomes simply ln x times sine x plus this and that are cancelled, becomes 1. 1 times sine x is just sine x. And then plus the whole thing. So that's the derivative of this. I haven't talked about why the chain rule is true, if you remember. I have skipped that one. I haven't talked about why this rule is correct, but I just told you why the rule is correct for the 3-1 if you take this for granted. I will come back to these later, okay? My purpose in this lesson is to learn how to use them. And that is the only thing that you need for the exam, of course. But it is always good to understand why this happens, that the formula for the product becomes more complicated than the formula for the addition. So by the way, I have to go here and add it here. So fg prime is f prime g plus fg prime. And I will add one more to it here. Okay, so the next rule that you were expecting, as you mentioned, is the quotient rule. What happens if I have the division of two functions? Yes? Okay, so this is called the quotient rule now. So the quotient rule is actually a very nasty rule. I will always avoid this as much as possible. So the quotient rule. The quotient rule, for example, if I have f of x equals to x over ln of x, if I ask you to differentiate this function. So the question is, what is the derivative of this function? So none of those rules is helpful. So the rule that I need to actually use is something, the division of two functions. Okay, so what is the correct rule? The correct rule is this. First of all, let me write the wrong version of it. So if you think that this is equal to f prime over g f prime, that is not correct. The correct version is this. F over g prime is equal to the derivative of the numerator multiplied by the denominator itself minus the numerator itself multiplied by the derivative of the denominator divided by the denominator to the power of 2. So this is the chain rule. Sorry, this is the quotient rule. So that I will add here. So let me also add it here. There is nothing that even in the university you will add here. So these kind of rules are finished here. So f over g prime is f prime g minus fg prime divided by g squared. So I told you again, in principle I should tell you why this formula is correct, but I skipped. There might be in one session I will talk about why the chain rule, the product rule, and the quotient rules are correct. But you need to learn how to use them. But the using them is extremely simple. Yeah, so I give you this function, and I want you to calculate f prime. So what you are supposed to do, so you would say that, okay, I want to take the derivative of this function. But this tells you that the derivative of the numerator multiplied by the denominator itself minus the numerator itself multiplied by the derivative of the denominator and then divided by the denominator to power 2. Yes? And the derivative of x is 1 multiplied by ln of x. The derivative of ln of x is on the board. It is 1 over x. But that 1 over x that you see here will be cancelled by this x. X times 1 over x is simply 1. And then divided this expression to power 2, which people usually write it like this rather than putting brackets. So that will be the derivative of this function. The only thing that is left, and I will complete the lesson by that, is to add one row here, and then that is the question that I asked. what happens if I have tangent x here? But hopefully now you understand that using the quotient rule I can answer this question. Yes, because if you ask me what is the derivative of tangent, instead of tangent, I write sine divided by cosine. This is the definition of tangent, and I then take the derivative. But this is a fraction, and I learned just right now how to differentiate a fraction. So this becomes the derivative of the numerator multiplied by the denominator minus the derivative minus the numerator multiplied by the derivative of the denominator. Yes, and then divided by the denominator to power 2. Yes? Okay, but we know already that sine x prime is cosine. Cosine x prime is minus sine. So I will continue. Instead of the first part, I would write cosine times, there is another cosine here, and then sine minus sine multiplied. The derivative of cosine is minus sine, divided by the whole expression, it is 1 to power 2. But the numerator becomes cosine to the power of 2x, minus minus plus, sine times sine is sine squared, over, but what is this? This is just 1. Then it becomes 1 over cosine to the power of 2x. So the formula for the derivative of tangent is 1 over cosine squared x. Yes? Okay, some books, they write it a little bit differently. That is also good to know. Instead of going in this way, they divide this by that, it becomes 1. It's a little bit strange, but this is very common in university texts. You divide this by that, it becomes 1. You divide this by that, it becomes tangent squared. Because it is good, if you start with tangent and you want to take the derivative of tangent, it is better to express it in terms of the function itself. So some books you see they write this as the formula. Both of them are the same thing. So let me also add this one, but I think your book is only talking about this version. So some books they write it in that form. Again, when I say tangent, you need to remind yourself of chain rule version of that. So what is the answer to this? Tangent of u prime. You replace x with u. But the only thing that matters here is you remember to multiply by an extra u prime. So whenever you have a formula in that, you can write the chain rule version of that yourself immediately. Yes, is that understandable? Okay, so I will complete a little bit. So mainly, if you are interested to know things, why it works, so might be you are interested to see why this formula is working. If you are not interested, nothing you will lose in the exam. So the exam is just taking the derivatives and things like that, even in the national exam. But I think this is not a good attitude to just memorize things that they work. But it's better to understand them, okay? So I will stop here and then continue later. Any questions? Yes?
What happens if we have three?
Pardon, may you repeat it?
What happens if we have three functions on the question?
No, this doesn't make sense here. 3 functions, how?
I don't know.
Okay, you should tell me how, yes? But I mean, so for example, you might say that, okay, what happens, because you know when I talk about the product, I can imagine more than 3 functions multiplied, but I cannot usually imagine more than functions being divided, yes? So for example, you can write f over g over h, yes? How do you solve that problem?
What, for example, what if we have x squared plus 1 over something, or than x.
No, that is the same formula. That is not three functions. So if you say x squared plus 1 divided by ln of x, then the whole thing is your f. Yes? I was thinking you were talking about that. That's also a good question, by the way. How do you answer this? This is apparently the division of three functions. So if I ask you to, let me also record this. Yeah, it's recording, okay. So what is the derivative of this one then?
You mean like you take like p over h as a fraction or something?
You can do that, but you really don't need to just go from scratch, because f over g over h is another name for what? fh over g. And then you take the derivative of this one. Of course, then this is your numerator. So this is a combination of the product and the quotient group. Yes? Yes? And then this part becomes the product group, because that's a product. So then it becomes f prime hg plus f h prime g minus fhg prime divided by g squared. This becomes this. But for your question, you don't need to consider this as three functions. The whole numerator is your function in the numerator. The whole denominator is your function in the denominator. Yes? Yes, that's correct. Okay.